Lesson 1-8, Vector Addition. Vectors are measurements with magnitude and direction. We represent vectors with arrows. The length of the arrow is the magnitude, so a longer arrow has a bigger value than a shorter arrow. And the direction of the arrow is the direction. Vectors can be represented in component form. What's that mean? It means we make a right triangle with a vector as the hypotenuse. And so then you've got these two other sides of the right triangle. They are the components. We're going to use sine and cosine to find the horizontal, or x component, and the vertical, or y component. So if you don't remember, I'll give you the formulas for sine and cosine in a second. We give negative signs to anything going down or left. So up and right is positive. Sine is the opposite over hypotenuse. So if this is our angle, across from it is opposite. Hypotenuse is the diagonal one. And the adjacent is the side that is touching the angle. Football player kicks the ball at 15 meters per second at 30 degrees above the ground. So here's the football. It's on the ground. He kicks it that way. That's a 30-degree angle, and the vector is 15 meters per second. The components would be the sides of the right triangle. This would be the Vx, the velocity in the x component, and velocity y component. To find the x component, we'd look and see, Vx is the adjacent side, and the 15 is the hypotenuse. It means we'd use cosine. It is the adjacent over the hypotenuse. Notice if I multiply by hypotenuse, I get adjacent is hypotenuse times cosine of the angle. Or in other words, Vx would be 15 meters per second times cosine of 30 degrees, or about 13.0 meters per second. For the y is the opposite side, and I know the hypotenuse, the opposite hypotenuse would be sine. Again, notice if I multiply both sides by hypotenuse, I get the opposite as hypotenuse times sine of the angle. So the opposite was Vy, the hypotenuse is 15 meters per second, the angle is 30. So Vy is 7.5 meters per second. Now I had it going left, so we might choose to say that the velocity in the x is negative because it's going left. The velocity going in the y is going up, so it's positive. Very often we end up just saying that the x component is our vector times cosine of the angle, and the y component is our vector times sine of the angle. But be careful. What if our angle is not there? What if our angle is measured to a y? Then it would be the other way around. So before you just blindly put things, please look and see where the angle is. Scalar multiplication. When you multiply a vector by a single number, the single number is a scalar. So we draw the vector that many times. So here we have vector v, here we have 2v, so it's just there twice. Or half of v, it's there half as much. Also means you'd multiply the components of that vector by that number. A negative vector means you multiply it by -1, so it goes in the opposite direction. How can we add vectors, though? Well, there's two ways. Here's the graphical method. You draw the first vector. And then you draw the second vector where the first one ends. So vector A ended there, so then we draw vector B. Vector B ends there, so then we draw vector C. Call it tip to tail. The resultant vector goes from where the very beginning to the very end. And that resultant is A plus B plus C. So then you just have to measure the resultant's length and direction. Some people don't like adding vectors graphically, though, because it takes a lot of effort to very carefully draw everything. So what if there's an algebraic method called the component method? So vectors describe how can be described by its components to show how far it goes in the x and y directions. So on our picture here, vector A goes that far in the x and that far in the y. To add vectors, you simply add the x components and the y components. So as you can see in our pictures, here's how far it went in A, and the x and the y. And then I have B here. So it went up that much more B and over that much more BX. And that gives you the same C. So we can just rearrange so we can add up the x's and we can add up the y's. And it gives us the same thing as for C. So you need to find all the components for all the vectors, add all the x components, add all the y components, use the Pythagorean theorem to find the magnitude of the resultant, use inverse tangent to find the direction, and the direction is always found at the tail end of the resultant. Drawing pictures helps immensely. Please draw your pictures. Let's add these vectors. Vector C is 15 meters at 25 degrees north of east. That means from the east, which is to the right, I'm going upwards towards the north, 25 degrees. Vector D is 20 meters at 60 degrees south of east. So here's east. And it would be 60 degrees downwards. So what I'm going to do is I'm going to make a table. I'm going to have x, y, vector C, vector D. And then I'm going to get my components. So this would be Cx, that one would be Cy. And C itself is 15 meters. So x, that's my adjacent. So Cx would be 15 meters times cosine of 25. And I use cosine because it's the adjacent, which is 13.6 meters. For the y is the opposite. So that means I could just say 15 meters times sine, using sine because it's the opposite, which gets me 6.34. Now let's check for positives and negatives. Well, I'm going to the right and I'm going up. Those are both positive. Now for vector D, here's dx, dy, and d itself is 20 meters. X is the adjacent side, so it's going to be cosine. So it'd be 20 meters times cosine of the angle, which is 10 meters. The y is opposite the angle, so I'd use sine. So it'd be 20 meters times sine of the angle, which is 17.32 meters. Now let's check for positives and negatives. It's going to the right, so that's positive, but it's going down, so the y component is negative. So now I can add these. I have my components, now add them. So look at 23.6 for the x and negative 10.98 for the y. So what does that mean? Well, that means that our resultant goes 23.6 horizontally and goes 10.98 downwards vertically. So to find my resultant, I could use the Pythagorean theorem. So it would be the x component squared plus the y component squared, and then the square root of that, because it's a squared equals b squared plus c squared, or c squared equals a squared plus b squared, whatever. So you'll end up square rooting. So I put that through my calculator and I get 26.0 meters. Now what about the angle? That's my angle there at the tail of the R. So I could use, the 10.98 is the opposite, 23.6 is the adjacent. I could use tangent. Tangent of the angle is the opposite over the adjacent. The opposite was 10.98. Adjacent is 23.6. Use inverse tangent of that to get the angle. Use inverse when you're looking for the angle. And I get an angle of 25.0 degrees. Now, which way is that? Well, that was from the east going downwards. So that would be south of east. So my answer will be 26.0 meters at 25.0 degrees south of east. Now it's south of east because we started at the east and went south. Let's try another. A jogger runs 145 meters in the direction of 20 degrees east of north, then 105 meters in the direction of 35 degrees east to south of east. Determine the magnitude and direction of the jogger's position from our starting point. So the first one I'm going to call A is 145 meters and 20 degrees east of north. Well, here's north, up and down. We went east of that, so we went towards the right, 20 degrees. And its length was 145 meters. Vector B is south of east, so it's 35 degrees south of east, so from the east going south. And its length was 105 meters. So we'll make a table. So for A, the x component now is opposite the angle. Since the x component is opposite the angle, for the x we will use sine because it is opposite the angle of 20 degrees. For the y, that's adjacent to the angle, so it would be cosine. Put those in the calculator, I get 49.6 meters and 136.3 meters. This is going up and to the right. Both of those are positive. Vector B. The x component is adjacent to this angle. So since it's adjacent to this angle, I would use the adjacent, which is cosine 35. Put that in my calculator, get 86.0. And the y component is opposite the angle, so it will be sine, which is 60.2 meters. That is going to the right, which is positive, but is going down, which is negative. So the y component is going to be negative because it's going down. Add those together and you get r. So we get 135.6 meters and 76.1 meters. Which means we're going east, 135.6. We're going north, 76.1. So our resultant would be like that. To find the length of the resultant, use the Pythagorean theorem. Put that in my calculator, I get 155.5 meters. To get my angle, use tangent. My angle is always at the tail. So the opposite is 76.1. The adjacent is 135.6. Use inverse tangent of that. And my calculator says it is 29.3 degrees. But which way? Well, it's from the east, and we went up from there, north of there, so it was north of east. Started at the east and went north. So it looks like my final answer is that this jogger is 155 or 156 meters at 29.3 degrees north of east from her starting position.